Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Machine Learning Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
You are developing an ML model on Vertex AI that needs to meet specific interpretability requirements for regulatory compliance. You want to use a combination of model architectures and modeling techniques to maximize accuracy and interpretability. How should you create the model? The options are: Option A, use a convolutional neural network, CNN-based deep learning model architecture, and use local interpretable model agnostic explanations, LIME, for interpretability. Option B, use a recurrent neural network, RNN-based deep learning model architecture, and use integrated gradients for interpretability. Option C, use a boosted decision tree-based model architecture, and use SHAP values for interpretability. Option D, use a long short-term memory, LSTM-based model architecture, and use local interpretable model agnostic explanations, LIME, for interpretability.
To arrive at the correct answer, we focus on the keywords: interpretability requirements for regulatory compliance, maximize accuracy and interpretability.
The correct answer is option C, use a boosted decision tree-based model architecture, and use SHAP values for interpretability.
Why is this correct? C. Boosted decision trees offer a strong balance of high accuracy and inherent interpretability compared to deep learning models. Combined with SHAP values, they provide robust, consistent explanations suitable for meeting strict regulatory compliance requirements. Why are the others incorrect? A. CNNs are highly complex deep learning models that are inherently opaque. While LIME provides local explanations, starting with a black box model makes it difficult to satisfy strict regulatory interpretability requirements. B. RNNs are complex, nonlinear models primarily for sequence data and lack inherent interpretability. Even with integrated gradients, they are less suited than tree-based models when maximizing interpretability for regulatory compliance is required. Why are the others incorrect? D. LSTMs are complex deep learning architectures with low inherent interpretability. Using LIME provides some insight, but an LSTM is fundamentally a black box, making it suboptimal for strict regulatory compliance.
You need to train a ControlNet model with Stable Diffusion XL for an image editing use case. You want to train this model as quickly as possible. Which hardware configuration should you choose to train your model? The options are: Option A, configure 1A2 HiGPU 1G instance with an NVIDIA A100 GPU with 80 GB of RAM. Use Float 32 precision during model training. Option B, configure 1A2 HiGPU 1G instance with an NVIDIA A100 GPU with 80 GB of RAM. Use Float 16 quantization during model training. Option C, configure 4-in-1 standard 16 instances, each with one NVIDIA Tesla T4 GPU with 16 GB of RAM. Use Float 32 precision during model training. Option D, configure 4-in-1 standard 16 instances, each with one NVIDIA Tesla T4 GPU with 16 GB of RAM. Use Floor 16 quantization during model training.
To arrive at the correct answer, we focus on the keywords: ControlNet model with Stable Diffusion XL, train this model as quickly as possible, hardware configuration.
The correct answer is option B, configure 1A2 HiGPU 1G instance with an NVIDIA A100 GPU with 80 GB of RAM. Use Float 16 quantization during model training.
Why is this correct? B. An A100 GPU with 80 GB RAM provides sufficient VRAM for Stable Diffusion XL. Using Float 16 quantization reduces memory footprint and accelerates training speed significantly compared to Float 32, without substantially compromising model quality. Why are the others incorrect? A. While the A100 hardware is excellent, using Float32 precision consumes twice the memory and is significantly slower to train compared to lower precision formats like Float16. C. Tesla T4 GPUs with 16GB RAM lack sufficient memory for efficient Stable Diffusion XL training. Furthermore, Float32 precision is slower and requires more memory. D. Despite using lower precision, Tesla T4 GPUs with 16GB of VRAM do not have enough memory to efficiently handle the large memory requirements of training Stable Diffusion XL.
You recently deployed an image classification model on Google Cloud. You used Cloud Build to build a CI/CD pipeline for the model. You need to ensure that the model stays up to date with data and code changes by using an efficient retraining process. What should you do? The options are: Option A, use Cloud Run functions to monitor data drift in real time and trigger a Vertex AI training job to retrain the model when data drift exceeds a predetermined threshold. Option B, configure a Git repository trigger in Cloud Build to initiate retraining when there are new code commits to the model's repository and a pub/sub trigger when there is new data in cloud storage. Option C, use Cloud Scheduler to initiate a daily retraining job in Vertex AI pipelines. Option D, configure Cloud Composer to orchestrate a weekly retraining job that includes data extraction from BigQuery, model retraining with Vertex AI training, and model deployment to a Vertex AI endpoint.
To arrive at the correct answer, we focus on the keywords: Cloud Build, stays up to date with data and code changes, efficient retraining process.
The correct answer is option B. Configure a Git repository trigger in Cloud Build to initiate retraining when there are new code commits to the model's repository and a pub/sub trigger when there is new data in cloud storage.
Why is this correct? B. Cloud Build integrates natively with Git repository triggers for code changes and uses pub/sub triggers from cloud storage for data changes, efficiently fulfilling both requirements. Why are the others incorrect? A. Monitoring data drift in real time with Cloud Run functions is overly complex and does not efficiently address retraining explicitly triggered by code changes. C. Scheduled daily retraining does not efficiently react to actual data and code changes, potentially causing unnecessary retraining or delayed model updates. D. Weekly scheduled retraining with Cloud Composer is less efficient for dynamic updates and does not trigger directly on data or code changes.
You are an AI engineer that works for a popular video streaming platform. You built a classification model using PyTorch to predict customer churn. Each week, the customer retention team plans to contact customers that have been identified as at risk of churning with personalized offers. You want to deploy the model while minimizing maintenance effort. What should you do? The options are: Option A, use Vertex AI's pre-built containers for prediction. Deploy the container on Cloud Run to generate online predictions. Option B, use Vertex AI's pre-built containers for prediction. Deploy the model on Google Kubernetes Engine (GKE) and configure the model for batch prediction. Option C, deploy the model to a Vertex AI endpoint and configure the model for batch prediction. Schedule the batch prediction to run weekly. Option D, deploy the model to a Vertex AI endpoint and configure the model for online prediction. Schedule a job to query this endpoint weekly.
To arrive at the correct answer, we focus on the keywords: each week, minimizing maintenance effort.
The correct answer is option C. Deploy the model to a Vertex AI endpoint and configure the model for batch prediction. Schedule the batch prediction to run weekly.
Why is this correct? C. Vertex AI batch prediction is ideal for weekly scheduled jobs. Vertex AI is a fully managed service, which minimizes maintenance effort compared to managing custom deployments or clusters. Why are the others incorrect? A. Cloud Run is designed for real-time, online predictions, not weekly scheduled batch processing, and requires more manual configuration. B. Managing a model on Google Kubernetes Engine (GKE) require significant operational overhead, which contradicts the goal of minimizing maintenance effort. D. Online prediction endpoints run continuously for real-time requests. Querying a continuously running endpoint weekly is highly inefficient and unnecessary for batch workloads.
You are building an application that extracts information from invoices and receipts. You want to implement this application with minimal custom code and training. What should you do? The options are: Option A, use the Cloud Vision API with text_detection type to extract text from the invoices and receipts, and use a pre-built natural language processing (NLP) model to parse the extracted text. Option B, use the Cloud Document AI API to extract information from the invoices and receipts. Option C, use Vertex AI Agent Builder with the pre-built layout parser model to extract information from the invoices and receipts. Option D, train an AutoML natural language model to classify and extract information from the invoices and receipts.
To arrive at the correct answer, we focus on the keywords: extracts information from invoices and receipts, minimal custom code and training.
The correct answer is option B, use the Cloud Document AI API to extract information from the invoices and receipts.
Why is this correct? B. Cloud Document AI provides specialized, pre-trained parsers specifically designed for extracting structured data from documents like invoices and receipts without requiring custom ML training or complex code. Why are the others incorrect? A. Cloud Vision API extracts raw text via OCR but lacks native structured parsing. You would need custom code and NLP models to parse the text into specific fields, violating the minimal code requirement. C. Vertex AI Agent Builder is primarily focused on search and conversational applications. It is not the specialized, out-of-the-box solution for structured document processing and data extraction from invoices like Document AI. D. Training an AutoML natural language model requires gathering a custom dataset and performing training. This violates the explicit requirement to use minimal custom code in training.
You are building a TensorFlow text-to-image generative model by using a dataset that contains billions of images with their respective captions. You want to create a low-maintenance, automated workflow that reads the data from a cloud storage bucket, collects statistics, splits the dataset into training/validation/test datasets, performs data transformations, trains the model using the training/validation datasets, and validates the model by using the test dataset. What should you do? The options are: Option A, use the Apache Airflow SDK to create multiple operators that use Dataflow and Vertex AI services. Deploy the workflow on Cloud Composer. Option B, use the MLflow SDK and deploy it on a Google Kubernetes Engine cluster. Create multiple components that use Dataflow and Vertex AI services. Option C, use the Kubeflow pipelines, KFP, SDK to create multiple components that use Dataflow and Vertex AI services. Deploy the workflow on Vertex AI pipelines. Option D, use the TensorFlow Extended, TFX, SDK to create multiple components that use Dataflow and Vertex AI services. Deploy the workflow on Vertex AI pipelines.
To arrive at the correct answer, we focus on the keywords: TensorFlow, low maintenance, automated workflow, collects statistics, splits the dataset, data transformations, trains the model, validates the model.
The correct answer is option D, use the TensorFlow Extended, TFX, SDK to create multiple components that use Dataflow and Vertex AI services. Deploy the workflow on Vertex AI pipelines.
Why is this correct? D. TFX is specifically designed for production-scale TensorFlow pipelines, providing pre-built components, like statistics gen, transform, evaluator, that handle these exact steps. Deploying on Vertex AI pipelines provides the required low-maintenance, managed environment. Why are the others incorrect? A. Apache Airflow on Cloud Composer is a general-purpose orchestrator that requires more custom development and lacks the out-of-the-box machine learning and TensorFlow data processing components provided by TFX. B. Managing a Google Kubernetes engine cluster for MLflow introduces significant infrastructure management overhead, which violates the requirement for a low-maintenance workflow. Why are the others incorrect? C. While KFP is a strong orchestrator, TFX is explicitly optimized for TensorFlow models and includes built-in, specialized components for tasks like statistics collection and data transformations that KFP would otherwise require you to build from scratch.
Your company manages an e-commerce website. You developed an ML model that recommends additional products to users in near real time based on items currently in the user's cart. The workflow will include the following processes. 1. The website will send a pub/sub message with the relevant data and then receive a message with the prediction from pub/sub 2. Predictions will be stored in BigQuery 3. The model will be stored in a cloud storage bucket and will be updated frequently. You want to minimize prediction latency and the effort required to update the model. How should you reconfigure the architecture? The options are: Option A, write a cloud function that loads the model into memory for prediction. Configure the function to be triggered when messages are sent to pub/sub. Option B, create a pipeline in Vertex AI pipelines that performs pre-processing, prediction, and post-processing. Configure the pipeline to be triggered by a cloud function when messages are sent to pub/sub. Option C, expose the model as a Vertex AI endpoint. Write a custom DoFn in a Dataflow job that calls the endpoint for prediction. Option D, use the Run Inference API with watch file pattern in a Dataflow job that wraps around the model and serves predictions.
To arrive at the correct answer, we focus on the keywords: near real-time, send a pub/sub message, updated frequently, minimize prediction latency, effort required to update the model.
The correct answer is option D. Use the Run Inference API with watch file pattern in a Dataflow job that wraps around the model and serves predictions.
Why is this correct? D. The Run Inference API in Dataflow provides low latency predictions natively. Watch file pattern automatically detects new model files in cloud storage and updates the model dynamically without restarting the streaming job, minimizing both latency and update effort. Why are the others incorrect? A. Loading the model in a cloud function introduces cold start delays and overhead for frequent invocations, failing to minimize prediction latency. B. Vertex AI pipelines are intended for batch processing or model training orchestration, not for near real-time, low-latency streaming predictions. C. Making external network calls to a Vertex AI endpoint from a Dataflow DoFn adds significant latency compared to doing inference locally within Dataflow using Run Inference.
You work for a magazine publisher and have been tasked with predicting whether customers will cancel their annual subscription. In your exploratory data analysis, you find that 90% of individuals renew their subscription every year, and only 10% of individuals cancel their subscription. After training a NN classifier, your model predicts those who cancel their subscription with 99% accuracy and predicts those who renew their subscription with 82% accuracy. How should you interpret these results? The options are: Option A, this is not a good result because the model should have a higher accuracy for those who renew their subscription than for those who cancel their subscription. Option B, this is not a good result because the model is performing worse than predicting that people will always renew their subscription. Option C, this is a good result because predicting those who cancel their subscription is more difficult, since there is less data for this group. Option D, this is a good result because the accuracy across both groups is greater than 80%.
To arrive at the correct answer, we focus on the keywords: predicting whether customers will cancel, 90% of individuals renew, 10% of individuals cancel, predicts those who cancel their subscription with 99% accuracy.
The correct answer is option C. This is a good result because predicting those who cancel their subscription is more difficult, since there is less data for this group.
Why is this correct? C. Predicting the minority class, cancellations, is typically harder due to limited training data. Achieving 99% accuracy on this 10% subset is excellent and directly addresses the primary business goal of identifying potential cancellations. Why are the others incorrect? A. The business priority is identifying cancellations, the minority class. Therefore, having a higher accuracy for cancellations is more important and beneficial than having a higher accuracy for renewals. B. Although the model's overall accuracy, 83.7%, is lower than a naive baseline of always predicting renewals, 90%, the baseline identifies zero cancellations. The model successfully identifies 99% of cancellations, which is the actual objective. D. Simply exceeding an 80% accuracy threshold is not a valid justification for success, especially in imbalanced datasets where a naive majority class prediction could easily achieve 90% overall accuracy.
You are training a large-scale deep learning model on a cloud TPU. While monitoring the training progress through TensorBoard, you observe that the TPU utilization is consistently low and there are delays between the completion of one training step and the start of the next step. You want to improve TPU utilization and overall training performance. How should you address this issue? The options are: Option A, apply tf.data, dataset.map with vectorized operations and parallelization. Option B, use tf.data, dataset.interleave with multiple data sources. Option C, use tf.data, dataset.cache on the dataset after the first epoch. Option D, implement tf.data, dataset.prefetch in the data pipeline.
To arrive at the correct answer, we focus on the keywords. TPU utilization is consistently low, delays between the completion of one training step and the start of the next step.
The correct answer is option D, implement tf.data dataset.prefetch in the data pipeline.
Why is this correct? D. Implementing prefetch overlaps data pre-processing and model execution. It prepares the next batch while the current one is training, directly addressing the delay between steps and increasing TPU utilization. Why are the others incorrect? A. While parallelizing map operations speeds up data transformation, it does not fundamentally decouple data production from consumption to eliminate the idle time between training steps. B. Interleave speeds up data loading by parallelizing reads from multiple files, but prefetching is still required to overlap the data pipeline with model training on the TPU. C. Caching stores data in memory after the first epoch, which is often impossible for large datasets and does not explicitly overlap data preparation with model execution.
You are building an ML pipeline to process and analyze both steaming and batch datasets. You need the pipeline to handle data validation, pre-processing, model training, and model deployment in a consistent and automated way. You want to design an efficient and scalable solution that captures model training metadata and is easily reproducible. You want to be able to reuse custom components for different parts of your pipeline. What should you do? The options are: Option A, use Cloud Composer for distributed processing of batch and streaming data in the pipeline. Option B, use Dataflow for distributed processing of batch and streaming data in the pipeline. Option C, use Cloud Build to build and push Docker images for each pipeline component. Option D, implement an orchestration framework such as Kubeflow pipelines or Vertex AI pipelines.
To arrive at the correct answer, we focus on the keywords: ML pipeline, handle data validation, pre-processing, model training, and model deployment in a consistent and automated way, captures model training metadata, reuse custom components.
The correct answer is option D, implement an orchestration framework such as Kubeflow pipelines or Vertex AI pipelines.
Why is this correct? D. Vertex AI pipelines and Kubeflow pipelines are explicitly designed to orchestrate ML workflows. They automate steps from validation to deployment, capture model metadata natively, ensure reproducibility, and support reusable custom components. Why are the others incorrect? A. Cloud Composer is a general-purpose workflow orchestration service based on Apache Airflow. It lacks native ML metadata tracking and specialized ML component management required for this scenario. B. Dataflow is a managed service for distributed data processing. It is not an ML pipeline orchestration framework and cannot handle end-to-end ML processes like model training, deployment, or metadata tracking. C. Cloud Build is a CI/CD platform used to create and deploy container images. It is not an orchestration framework for executing ML pipelines or tracking model metadata.
You have developed a fraud detection model for a large financial institution using Vertex AI. The model achieves high accuracy, but the stakeholders are concerned about the model's potential for bias based on customer demographics. You have been asked to provide insights into the model's decision-making process and identify any fairness issues. What should you do? The options are: Option A, create feature groups using Vertex AI Feature Store to segregate customer demographic features and non-demographic features. Retrain the model using only non-demographic features. Option B, use feature attribution in Vertex AI to analyze model predictions and the impact of each feature on the model's predictions. Option C, enable Vertex AI model monitoring to detect training serving skew. Configure an alert to send an email when the skew or drift for a mode's feature exceeds a predefined threshold. Retrain the model by appending new data to existing training data. Option D, compile a dataset of unfair predictions. Use Vertex AI vector search to identify similar data points in the model's predictions. Report these data points to the stakeholders.
To arrive at the correct answer, we focus on the keywords: bias based on customer demographics, insights into the model's decision-making process, identify any fairness issues.
The correct answer is option B, use feature attribution in Vertex AI to analyze model predictions and the impact of each feature on the model's predictions.
Why is this correct? B. Feature attribution in Vertex Explainable AI details how much each feature contributes to predictions. This provides the required insights into the decision-making process, helping to identify if demographic features are disproportionately driving the model's outcomes. Why are the others incorrect? A. Removing demographic features, fairness through blindness, often fails because other features act as proxies. Furthermore, this approach does not provide insights into the current model's decision-making process. C. Vertex AI model monitoring is designed to detect data drift and training serving skew over time, not to explain a model's internal decision-making process or identify inherent fairness issues. Why are the others incorrect? D. Vertex AI vector search is used for similarity matching with embeddings. It does not explain how the model makes its decisions or quantify individual feature impacts to evaluate fairness.
You work for an e-commerce company that wants to automatically classify products in images to improve user experience. You have a substantial dataset of labeled images depicting various unique products. You need to implement a solution for identifying custom products that is scalable, effective, and can be rapidly deployed. What should you do? The options are: Option A, develop a rule-based system to categorize the images. Option B, use a TensorFlow deep learning model that is trained on the image dataset. Option C, use a pre-trained object detection model from Model Garden. Option D, use AutoML Vision to train a model using the image dataset.
To arrive at the correct answer, we focus on the keywords: classify products in images, substantial dataset of labeled images, custom products, scalable, effective, and can be rapidly deployed.
The correct answer is option D, use AutoML Vision to train a model using the image dataset.
Why is this correct? D. AutoML Vision enables rapid deployment of highly scalable and effective machine learning models trained on your custom labeled image dataset, perfectly satisfying all business requirements. Why are the others incorrect? A. Rule-based systems are rigid, difficult to scale, and generally ineffective for complex tasks like classifying diverse and unique products in images. B. Building and training a custom TensorFlow model from scratch requires significant development time and ML expertise, which violates the requirement for rapid deployment. C. A pre-trained model from Model Garden is designed for general objects and would not be able to identify your company's unique custom products without additional fine-tuning.
You work on a team that builds state-of-the-art deep learning models by using the TensorFlow framework. Your team runs multiple ML experiments each week, which makes it difficult to track the experiment runs. You want a simple approach to effectively track, visualize, and debug ML experiment runs on Google Cloud while minimizing any overhead code. How should you proceed? The options are: Option A, set up Vertex AI experiments to track metrics and parameters. Configure Vertex AI TensorBoard for visualization. Option B, set up a cloud function to write and save metrics files to a cloud storage bucket. Configure a Google Cloud VM to host TensorBoard locally for visualization. Option C, set up a Vertex AI Workbench notebook instance. Use the instance to save metrics data in a cloud storage bucket and to host TensorBoard locally for visualization. Option D, set up a cloud function to write and save metrics files to a BigQuery table. Configure a Google Cloud VM to host TensorBoard locally for visualization.
To arrive at the correct answer, we focus on the keywords TensorFlow framework, track the experiment runs, track, visualize, and debug ML experiment runs on Google Cloud, minimizing any overhead code.
The correct answer is option A, set up Vertex AI experiments to track metrics and parameters. Configure Vertex AI TensorBoard for visualization.
Why is this correct? A. Vertex AI Experiments is a managed service for tracking ML parameters and metrics. Vertex AI TensorBoard offers managed visualization. Both seamlessly integrate with TensorFlow on Google Cloud, effectively solving the team's needs while minimizing overhead code. Why are the others incorrect? B. Building custom cloud functions and self-hosting TensorBoard on a VM introduces significant operational complexity and maintenance, directly contradicting the goal of minimizing overhead code. C. Self-hosting TensorBoard within a Workbench instance limits team accessibility and scalability. It requires manual setup and management, which introduces more overhead than using fully managed Vertex AI services. Why are the others incorrect? D. Storing metrics in BigQuery for TensorBoard visualization creates unnecessary integration complexity. Coupled with self-hosting TensorBoard on a VM, this approach maximizes rather than minimizes overhead code.
You are an ML engineer at a retail company. You have built a model that predicts a coupon to offer an e-commerce customer at checkout based on the items in their cart. When a customer goes to checkout, your serving pipeline, which is hosted on Google Cloud, joins the customer's existing cart with a row in a BigQuery table that contains the customer's historic purchase behavior and uses that as the model's input. The web team is reporting that your model is returning predictions too slowly to load the coupon offer with the rest of the web page. How should you speed up your model's predictions? The options are: Option A, attach an NVIDIA P100 GPU to your deployed models instance. Option B, use a low-latency database for the customer's historic purchase behavior. Option C, deploy your model to more instances behind a load balancer to distribute traffic. Option D, create a materialized view in BigQuery with the necessary data for predictions.
To arrive at the correct answer, we focus on the keywords, joins the customer's existing cart with a row in a BigQuery table, returning predictions too slowly, speed up your model's predictions.
The correct answer is option B, use a low-latency database for the customer's historic purchase behavior.
Why is this correct? B. BigQuery is an analytical data warehouse not designed for low-latency row retrieval during online serving. Replacing it with a low-latency NoSQL database like Cloud Bigtable or Memory Store for real-time feature retrieval eliminates this bottleneck and speeds up prediction serving. Why are the others incorrect? A. While GPUs accelerate model inference, the primary latency bottleneck described is the data retrieval from BigQuery, not the computational time of the model's inference. C. Adding more instances behind a load balancer increases throughput for handling more concurrent requests, but it does not reduce the individual prediction latency caused by the slow BigQuery lookup. D. Materialized views in BigQuery speed up complex analytical queries, but BigQuery still will not provide the millisecond level latency required for real-time online serving.
You are an ML engineer at a large grocery retailer with stores in multiple regions. You have been asked to create an inventory prediction model. Your model's features include region, location, historical demand, and seasonal popularity. You want the algorithm to learn from new inventory data on a daily basis. Which algorithms should you use to build the model? The options are: Option A, classification. Option B, reinforcement learning. Option C, recurrent neural networks, RNN. Option D, convolutional neural networks, CNN.
To arrive at the correct answer, we focus on the keywords: inventory prediction, historical demand, seasonal popularity, learn from new inventory data on a daily basis.
The correct answer is option C, recurrent neural networks, RNN.
Why is this correct? C. RNNs are well suited for sequential or time series data, making them ideal for predicting inventory using historical demand and seasonal trends, and they can learn from continuous daily updates. Why are the others incorrect? A. Classification is used to predict discrete categorical labels, whereas inventory prediction requires forecasting continuous numerical values based on time series data. B. Reinforcement learning focuses on an agent learning to make sequential decisions to maximize a reward, which is unnecessary for standard historical time series forecasting. D. Convolutional neural networks, CNN, are primarily designed for spatial data such as images, and are not the standard choice for sequential time series forecasting.